Welcome back to Scale Model Workshop and the second episode of building the Revell Monogram A26. Before I get back into the model, I wanted to let you know that I put up a web page with some additional information on the Revell Monogram A26, as well as the introductory pilot's training film on flying the A26, the pilot's manual, and World War II squadron markings. The link to the web page is in the description of the video below. The wing has quite a bit of flex, and I was a little wary of how stable it'd be when it's hanging from the ceiling for an indefinite period of time. So I used a mixture of slow-zap, cyanoacrylate, and free-flow dental resin powder to add a reinforcing rib down the center of the wing. A bead of the mixture was built up in the center of the wing. Using the slow-zap let me make a thick mixture with plenty of working time. To me, an extra thin cement was applied to the edges of the wing. Masking tape was used to keep the edges together, as well as keeping the two wing halves approximated while making adjustments to ensure that the wing is straight. After everything was set, the wing was much more rigid. The nacelle halves were assembled and the main gear doors taped in place. A mixture of slow-zap and acrylic powder was used to cement the doors, fill the gaps, and reinforce the joints. Once in place, they were given a preliminary sanding to knock down gross irregularities. Here you can see the low spots. I then went over the area with a thin coat of Zap-A-Gap cyanoacrylate. After final sanding, you can see that the surface is free of irregularities. Using cyanoacrylate rather than a solvent filler is much faster, and it ensures a surface that's stable to whatever primer or paint that I want to use. Also note that I removed all the cast-on detail. The nacelles were joined to the wings. But keep in mind, these type of joints always seem to have issues with alignment and warpage. With a combination of two wing halves, a split nacelle with large openings for the gear doors, and a fillet, you sort of have to decide on what fix would be the easiest. My priority is to make sure that the aft and front section of the nacelles line up with the upper wing halves as best as possible, and then just deal with the gaps between the fillet and the wing. Here you can see how different the spacing is when the nacelles lined up with the upper wing half. I filled the gaps with epoxy clay and sealed it with a thin coat of Zap-CA. From the standpoint of engineering and fit, the engine assembly is one of the real weak points of this kit. Looking inside the engine cowl flap piece, you can see how asymmetrical the parts are. When combined with the similarly shaped nacelle fronts, it's easy to wind up with some pretty obvious misalignment. I found this issue consistent with all the kits that I had. Since this project was all about overall appearance, my focus was more on general form and structure, and it's more important to make sure that the engines and nacelles lined up rather than getting sidetracked with small details that would go unnoticed. I found that depending on which parts were mated together, sometimes things were pretty close. So if you have the luxury to work from multiple kits, you can somewhat mitigate the alignment issues. However, if you're mixing and matching between kits, be aware that the first release of this kit had slightly different engine moldings. The earliest moldings didn't have the small raised tabs on the inside to support the nacelle fronts. With any of the combination of parts, the alignment can be improved by removing the pin from inside the engine cowl flap piece, and if necessary, do a little selective removal of material from the offending edge of the nacelle fronts. By themselves, the raised tabs don't provide much of a surface to glue to, especially after making some adjustments in the nacelle fronts. So the glue joint between these two pieces would be pretty weak. The quickest way I could see to reinforce the joint was to open up the nacelle fronts. Then after the two parts were cemented together with Tamiya extra thin cement, flow in some cyanoacrylate and acrylic. Every cowl in any of my kits had to one degree or another fairly prominent sink marks below the intake. I filled the depressions with my usual cyanoacrylate and acrylic powder mixture. Sandpaper wrapped around a dowel smooths out the excess filler and helps to straighten up the internal wall of the cowl. Because this part has to draw from a steel mold, there needs to be some amount of taper. Sanding with the dowel helps reduce some of the taper and lessens that molded look. A little creative use of a caliper provided a guide to add the panel line inside the cowl. When painting in a confined space like this, I find the best way to get an ultra-smooth surface is to use a smaller airbrush. Reduce the air pressure to around 8 to 10 pounds to minimize bounce back, and thin the paint accordingly so that it sprays well at the reduced pressure. In this case, I used Model Master Zinc Chromate thinned with lacquer thinner, and the result is a near eggshell finish. The fit of the cowl itself is pretty sloppy, so I added some shims from 30,000 styrene. These helped center the cowling. I wanted to get the entire assembly together and do some final shaping to blend all the contours, but I didn't want any solvent cement in the panel lines between the parts because it softens the styrene and makes it difficult to go back in quickly and re-establish sharp, consistent lines. My solution was to drill a few holes around the engine front. Then with the cowl in place, I flowed a little of the cyanoacrylate acrylic mixture through the holes. When everything was set up, I did a little sanding to blend the contours of the entire assembly together. I used both a 3-square and a slotting file to redefine the separations. Information about various Swiss pattern file shapes can be found on my website. Models like this are a good opportunity to experiment. So take something as common as how modelers typically attempt to represent the separation between aircraft panels. Looking at this high contrast surface of nearly black panels and white lines, you can see how fine the lines appear, even between the removable or movable panels. When viewed at a size more akin to the way we view our models, the lines virtually disappear. At the distance I'll be viewing these models at, the lines are insignificant. So in this case, I'll be maintaining the overly prominent panel lines around the cowl, developing panel lines where I've removed detail, and keeping the raised detail on the wings and empennage. I'm curious to see how they look together on a natural metal aircraft. I never know. I might stumble onto something I like better than the way I've done it in the past. After all, consistency is the last refuge of the unimaginative. Because of the limitation of injection molding, the separation of a molded-on control surface is almost always poorly represented. In an attempt to create an illusion of separation as well as differentiation from the other panel lines, kit manufacturers typically widen and somewhat deepen the separation. The result is almost always toy-like. For example, here's a typical aileron, and here's how it has to be molded to draw. You can see how shallow it is. So what many modelers do is apply some sort of wash to try and create an artificial shadow. But what results is a blackened stain extending onto the aileron that more resembles a serious oil leak. In reality, the separation varies depending on the functioning of each type of control surface, but in each case you can see how prominent and well-defined they are. The definition results from having depth and a shadow placed inward between the main structure and the movable control surface. What I attempt to do when I re-engrave is to add some undercut to create a depth and shadow, making it look more like a functioning separate unit. I always cut through the inboard and outboard separations using either a thin-bladed circular or hand saw. I carve in the undercut using either a scribe or an instrument that I've ground for this purpose. For anyone that's interested, I'll be covering these techniques and tools in more detail in a future video. It's not uncommon to see photos of a 9th Air Force A-26C fitted with 4 underwing gun pods. Unfortunately, Monogram only includes 2 in a kit. but since I had plenty of kits, that wasn't a problem. What was an issue for me was that they have that sort of ill-defined blob of plastic look. I thought I could just clean them up a bit, but the front of the pod has a very noticeable depression that was the main contributor to the blob look. The only way I could see to recontour the front of the pod was to remove the molded barrels. Then I could also add some definition around the openings of the gun barrels. This provides a perfect opportunity to demonstrate a typical way I use a manually operated machine. In this case, a combination drill press and mill. The one I have I built from a standard drill press stand and a Unimat head. Unlike automated machines, manually operated machines like this in many ways can be thought of as just a fancy way to hold a part and maintain an alignment, and that's how I used it here. It doesn't do anything magical. You still have to position everything by eye and guide the movements by hand. Because the opening for the gun barrel is larger than the barrel itself, I first cemented a piece of styrene inside the gun pod to actually support the barrel. The molded gun barrel was chucked up and used to help align the gun pod in a table clamp. Once the gun pod was clamped in place, the barrels were cut off and the holes were spotted and drilled. I first drilled all the way through for the barrel and then went back with a larger drill to just enlarge the opening. The depression in the front of the gun pod was filled with my standard mix of cyanoacrylate and acrylic powder. I hung the gun pods over the ends of cotton pliers so the material wouldn't slump. After reshaping up the fronts of the gun pods, I hit them with a quick coat of old-school lacquer primer. The solvents in a traditional high VOC lacquer primer can attack styrene, but because they're so volatile, they evaporate quickly. The benefit is that it sort of defuzzes the styrene and leaves a hard surface that can be cleaned up and sharpened easily. Finally, I stuck a piece of sandpaper to the wing surface with double-sided tape so I could refine the mating surface of the gun pod. While they're far from perfect, a little messing about has eliminated the concave contour, and the gun barrels now appear to be separate pieces. Just a note to the more novice builders. This sequence may seem more involved than it actually is. The combination of fast-setting materials and the ability to hold pieces in place accurately reduces the time to minutes, and the one-off nature is perfectly suited to this type of machine. Well, that's about it for the second episode on building the Revell Monogram A26, and I'll see you next time.